So today we want to look at graphing linear functions. And the key word in linear there is line. Talk about linear functions, we talk about line equations or equation of a line. Now here I have several, I have 10 of them. And I believe if we look at how we sketch these 10 linear functions, then we should be able to sketch any function, because it's one basic fundamental principle. Now technically when you're asked to sketch a line, really and truly you're sketching what we call a line segment, because a line continues on and on and on. So you really want to sketch really a portion of the line or a section of the line, or I would say a line segment, which is just a part of the line. Now the first one, x equal to. Now usually when we are sketching the equation of a line, you try and always show, we try to show where the line cut the axis. Alright? X and y axis. Now the line x equal to 2. Notice in the equation here, the variable is just x equal to 2. And the variable, so is one variable there, x. Alright? So this line will cut the x axis only at 2. Right? So this line will look something like this. So it cuts the x axis at 2. So the line x equal to would cut the x axis at 2. And it continues on and on and on. And when we sketch a line, we always try to label your graph. So that's line x equal to. And very importantly, this line cuts only the x axis. Look in the equation, the only variable there is x. X equals 0. We recognize the line x equals 0 is the y-axis. So line x equals 0, here's the x-axis, the horizontal axis. So the line x equals 0 will cut the x-axis at 0, which is really what the y-axis does, right? Alright, so this line will look something like that. Alright, and again, it's a segment of the line, because the line continues up, 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 and down, 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 right? So it's really a portion of the line of sketching, what we call a line segment. So line x equals 0 is equivalent to the y-axis. X equals minus 5, we look for 5 on the negative 5 on the x-axis. And again, this line cuts only the x-axis. And you can tell just by looking at the variables involved there, it's just x. So that's line x equals 5. Alright, or we call a line segment, that is x equal to 5, right? So that's a line x equal to minus 5, I should say, because it's cut the x-axis at minus 5. Good? Now let us look at 4, 5, and 6. So now we are sketching the line y equal to 5. So the line y equal to 5, so y equal to 5. So the only variable there is y. And cuts the y-axis at 5. So y equal to 5 is the y-axis, we'll call it vertical axis. So this line will cut the y-axis at 5, right? So this line, the segment of this line, of the line y equal to 5, will be that, right? So that's the line y equal to 5, or line segment y equal to 5. Because the line y equal to 5 continues as far right as you can possibly go, and it continues as far left as you can possibly go. Alright, we want to catch what we call a segment of the line. Y equals 0. Y equals 0. So y equals 4, y equals 3, 2, 1, and so forth. And y equals 0, you recognize that that is the x-axis. Alright, so line y equals 0 is the x-axis. Good. That's the other name for the line y equals 0. It's the x-axis, so it's the line y equals 0. Or the line segment y equals 0. And y equals minus 4. So we look for a negative 4 on the y-axis. We'll come here. So y equals negative 4. Of course, this line will cut the x-axis only. The only variable in this equation is y. It's a line y equal to 4. So it cuts the y-axis at minus 4. And it cuts only the y-axis, right? And we know it doesn't cut the x-axis because in the equation here, the only variable there is y. Just as with 4 and 5. Good, so this is a line y equal to minus 4. Now let us sketch the line x plus y is equal to 4. So we have done that. We've done all of these. So now we are sketching a line x plus y equal to 4. Now, as I said earlier, when you ask to sketch a line, what the two things you are looking out for is to show where the line cuts the x-axis and also where the line cuts the y-axis. So we have the line x plus y equal to 4. And of course, we know this line cuts both the x-axis and the y-axis. And how do we know that? Look at the variables in the equation, x and y. So we know it cuts both axes, the x and the y. So usually we want to try to find out where the graph cut each of the axes, alright? So it cuts x-axis when y is 0. Alright, so graph cuts the x-axis when y is 0. If you look at this now, when y is 0, we have x plus y equal to 4. So when y is 0, what you end up with is x plus 0 equal to 4. And x plus 0 is x, right? So x equal to 4. So the graph cuts x-axis at 4. So let me just put a little mark there. Good. And now we also want to know where the graph cuts the y-axis. So it cuts y-axis when x equal to 0. So to get where the graph cuts the y-axis, we'll let the x be 0 this time. So note we have x plus y equal to 4. So now we'll let the x be 0. So 0 plus y equal to 4. Oh, this is 0 plus y. 0 plus y is y, right? So y is equal to 4. So this graph cuts the y-axis at 4. And now we can draw our line segment. So, alright, so this graph cuts 4. It cuts both axes at 4, right? So this is a graph of the line x plus y is equal to 4. Good. Let's do y equal to x plus 4 now. Alright, so now we're doing the graph y equal to x plus 4. So again, you want to know two things. We want to know where the graph cuts the x-axis and you want to know where the graph cuts the y-axis. Let me deal with the y-axis first. Alright? So it cuts, graph cuts y-axis when x equals 0. Always. Always when x equals 0, right? Now when x equals 0, remember the equation of the line is y equal to x plus 4. But if x equals 0, then 2x will become 2 times 0. And 2 times 0 is 0, right? So all we have is y equal to 4. 0 plus 4. So it cuts the y-axis at 4. Good? You want to know where the graph cuts the x-axis now. Okay, so we just found it cuts the y-axis at 4. Yes. And it cuts the x-axis when y is 0. Alright, so when y is 0, here we let the y be 0. So what we have is 0 equal to x plus 4. And now we solve for x. We can subtract 4 from both sides. So we group 4 over here. So we group 4 over here. We have is minus 4 over here. And it's just 2x, right? It's positive 4 and there's no negative 4 over here. Divide both sides by 2. So 2 into 2, 1. So we have 1x. And then negative 4 divided by 2. We know negative divided by positive, that's negative, right? So negative 2. So x equal negative 2. So the graph cuts the x-axis at negative 2, which would be here. So it cuts the y-axis at 4, x-axis at negative 2. So the graph will pass through 4 on the x and the y, sorry, and minus 2 on the x. And we always good to label your graph. This is the graph of y equal to 2x plus 4. So we did this. Now we're doing the one of graph of y equal to 2x minus 5. So the graph cuts the y-axis when x is 0. When x is 0, all of this becomes 0, right? So y is negative 5. So this graph cuts the y-axis at minus 5, which is here. And it cuts x-axis when y is 0. Right? Now when y is 0, what you have is 0 equal to x minus 5. Alright, when y is 0 is 0. Oh, sorry, the graph was y equal to x minus 5. So when y is 0, 0 equal to x minus 5. You're solving for x, so the minus 5, group over here, or you say add 5 to both sides. So you have 5 equal to 2x. You want to solve for x, so you divide both sides by 2. So 2 into 2, that's 1, so 1x, and what's 5 divided? So x equal to 5 divided by 2. What's 5 divided by 2? 2.5. So 2.5 is somewhere, x is 2.5 would be somewhere about here. X is 2.5. X is 2.5 is somewhere about here. And we'll find the graph cut the y-axis where was negative 5. What was it? Negative 5, right? I put x, but it's not here. Right here. So it cuts the y-axis at negative 5 and cuts the x-axis at 2.5. So the graph would resemble something like this. Okay. So this is a graph of y equal to 2x minus 5. Now for the graph of 2x plus 3y equal to 12, again, we want to know where the graph cut each of the axes. So it cuts the y-axis at x equals 0. Now if x is 0, what you have is 2x will become 2 times 0, which is 0. So all you're left with is 3y is equal to 12. And if 3y is equal to 12, then we divide both sides by 3 to get the value of y. So 12 divided by 3 is 4. So this graph, it cut the y-axis at 4. And now we want to know where the graph cuts the x-axis. It cuts the x-axis when y is 0. When y is 0, what you have is 2x plus 3 times y. And y is 0, so 3 times 0 is 0. So it's just 2x on the left hand side and 12 on the right hand side. So you want to find the value of x. We divide both sides by 2. 2 into 2, that's 1. So 1x is equal to 12 divided by 2, which is 6. So this graph cuts the x-axis at 6. And now we can do a little sketch of the segment. Oh no. Alright, so that's the graph. 2x plus 3y is equal to 12. I believe that covers all the types we want to look at. Next video we'll be looking at sketching curve, what we call equation of the quadratic functions.